Good evening, Namaskar, Jai Shri Ram, Jai Shri Krishna. You are welcome to my channel Learn Statistics using R, where we present a series of statistical methods and statistical computing using R. Today's episode is number 3. Its topic is further topics of frequency distribution and cumulative frequencies, etc. Instructed as me, Dr. Akhileshsingh. I have been ex-professor and head at Indira Gandhi Agriculture University, Raipur, Chhattisgarh, India. Presentation today includes the topic of further topics of frequency distribution and cumulative frequencies. The first concept is relative frequency distribution, which I frame as relative frequency distribution is computed with respect to total relative frequency. Total frequency. That is when we divide the frequencies corresponding to distinct variable values by total frequency, then the outcome is the relative frequency distribution, whose total frequency is always 1. This concept is akin to the probability distribution. Thus, we can interpret it that the probability of a variable value is nothing but its corresponding relative frequency. Another definition is cumulative frequency distribution, which I frame as cumulative frequency is nothing but the frequencies that are accumulated along increasing values of a variable. Cumulation of frequencies may be of less than type as well as of more than type. Thus, when the frequencies are cumulated, that is added up cumulatively as the values of the variable increases, such frequencies are called less than type of cumulative frequencies. On the other hand, when the frequencies are cumulated negatively, that is are subtracted cumulatively as the values of the variable increases, such frequencies are called more than type of cumulative frequencies. Cumulative frequencies of less than type addresses a particular question, namely, what is the count of individuals whose variable, say x, measure is less than or equal to a given particular value of x. For example, suppose the value of x, say word length, in the word length example of Tagore, is 2 and its corresponding cumulative frequency is 12. What is the cumulative sum? Will be 1 plus 1 plus 10 equal to 12. Then this addresses the question, what is the count of words whose variable, say x, measure is less than or equal to the value of x equal to 2, and its answer is 12, which cumulates 1 plus 1 plus 10. Let me demonstrate you to a computation. In the word length example, I have pre-computed this and put it here for your demonstration. You see, suppose x represents the word length and f represents its frequencies. Then what is the cumulative frequency of less than type? It addresses a question. What is the number of words having word length 0 or more than it? It is always 1. What is the number of words having word length 1 or more than it? Is 2, because this frequency 1 and 1 for these two categories get added up, that is cumulated. What is the frequency of the number of words having word length 2 or less than it? So this is 12, where 1 plus 1 plus 10 are cumulated, as I was telling you in my presentation. What is the number of words having word length 3 or less than 3? So 19 plus 10 plus 1, like this. On the other hand, there is a concept of cumulative frequency of more than type that we shall now go to presentation, see how. Similarly, cumulative frequency of more than type addresses a particular question. What is the count of individuals whose variable x measure is more than or equal to the given particular value of x. For example, suppose the value of x is 8 and its corresponding cumulative frequency is 14, which is the cumulative sum 6, 3, 3, 1 and 14. So this addresses the question, what is the count of words whose variable measure is more than or equal to the value of 8, and its answer is cumulative sum 6, 3, 3, 1, 1 equal to 14. Let me show you in the demonstration. Here you see we are talking of this. So cumulative frequency of more than type, we are talking of this. So let me put the question, how many words are there having word length 0 or more than it? Remember, not less than, more than it. It means all, entire, all this. So the total is 89. So what is the number of words having length 1 or more than it? So this means minus this first category, this is 88, that is 89 minus 1. What is the number of words having length 2 or more than it? Its corresponding value is 87, because its previous two frequencies 1 and 1 are cumulatively subtracted, that is 1, 89 minus 1, 89, 88 minus 1 makes it 87. What is the number of words having word length 7 or more than it? This means all these are, subtract all before occurring frequencies from 89 to get 14. So this is what I was telling you about. Now going to presentation. Relative cumulative frequency. Relative cumulative frequency is nothing but we cumulate the relative frequencies just like we cumulated the frequencies. Let me demonstrate you. Thus, when the relative frequencies are cumulated positively, that is added cumulatively, they are called of less than type, and when subtracted cumulatively, they are called of more than type. Let me demonstrate. You see, this is the relative frequency. In the very beginning I told you its concept about. This is nothing but frequency divided by total frequency. Total frequency 89, if we divide all these frequencies by 89, we get this relative frequency. Now relative frequency of cumulative relative frequency of less than type is nothing but, what is, say, I'll put that question, what is the proportion, not the number, remember, not the number, what is the proportion of words, what is the proportion of words having 0 or less than it? It is same as this one. What is the proportion of words having word length 1 or less than it? So these two are cumulative. What is the proportion of words having 2 or less than? These three are cumulative. Similarly, on the reverse side, where relative frequency of more than type, what is the proportion of words having word length or more than it? So that means these, all these will, this one, because all these proportions will be added to make it this. What is the proportion of words having word length 8 or more than it? So this means all these will be added to make it this. Or say from 1 we subtract the previous ones. This is how the concept goes. Now let us compute relative frequency, cumulative relative frequency of less than more than type. So in this example, this is the first example, we have already computed in our previous lectures. Cumulative frequency is computed, relative frequency is computed by dividing f by n, that is total frequency, and cumulative frequency of less than type is obtained by this function cum-sum, that is, that cumulatively sums the frequencies. So if we use the transform function, it adds up these two columns in this data frame of x and f that we have already computed earlier. Now next thing is we need to compute cumulative frequency of more than type. This is a bit tricky, and for this we need this value of n. So what we do, we compute this concatenation function this is not function, concatenation vector. We add up or append, you say, the maximum frequency, 89. This is in the upper one, this is the first compulsory one. All the others can be obtained by subtracting cumulative sum from this n. And if you append this one, we get and remove the last one. Let me demonstrate you how does it do. In the demonstration, you see, we have already computed this. We will not repeat them. Now, you see, these two. This one I want to demonstrate. How do we compute it? You see this. This is this observation, okay? This is obtained by removing the last number. If we don't put it, what happens? You see, if we remove this, then we get this. This 0 is extra. You know why? Because 89 has been, this n has been appended before the n minus 1. Remember, this n minus 1, n already contains 12 observations. So this should 12 and this n, this makes 13. But we don't need the 13 one. Therefore, this n plus 1 is 13. So the minus 13, when put, we indirectly put minus 13, this goes away and we get, you see, we get this value by removing this. Okay, this is about the computational details. Now, let me go to our presentation. So, here I elaborated on this. Okay. Now, what we do now further, cumulative frequency of operant type that we have computed here, we transform it to make it this one. Then relative frequency is simply obtained by dividing by n. Relative cumulative frequency is obtained by dividing the cumulative frequency of less than type. Since it is frequency, if you divide by n, it becomes proportion of frequencies, that is the relative frequency. Okay. Now, in the second example, this is a continuous example. In this example, we have already done this, we will not repeat them. Okay. This one. So, just like in the discrete case, we get the two relative frequency as cumulative. Again, we use cum-sum function. Because computations are same, only the difference lies in the first and third and fourth column. Okay. Now, again, we store the n row, number of rows into n, and then we use the same technique as was in the case of discrete, and here also we obtain similarly. Let me demonstrate you. Okay. So, there you see, in the Indian adult male example, we have already computed this. You see this cumulative frequency of less than type. Then after storing number of rows in n, we compute similarly, and here n is equal to 8. So this ninth row that is obtained due to operation of this computation. There are 9 values in the vector. Ninth is removed because this n is already appended in the very beginning, which is must. Okay. So I have elaborated that technique in the discrete. We will not repeat that technique here again. So we obtain this. Now second is these cumulative frequencies. Okay. Let me go to our presentation. So this is how we obtain it. In the next is a definition 4, that is about the probability density and cumulative probability density. What is this? Probability density is the proportion of total frequency. Probability density is the proportion of total frequency with respect to class width. That means if we divide the relative frequency by the class width, this makes probability density. We will understand its concept later, but it is very relevant to tell it here. And its cumulative probability density is just by accumulation process, is nothing but the probability density that are cumulated along increasing values of the variable. Cumulation of probability density may be of less than type as well as of more than type. Probability density concept is useful in understanding the probability curve for continuous data type that we shall learn to create later. Let me demonstrate how. You see here, this is the example, a continuous example. There is no difference in the process of computation that we here. Here the only difference is the class names, and lower and upper boundaries are here. Okay. Relative frequencies are obtained by dividing frequencies by the total frequency. Cumulative frequencies are obtained similarly, just like. So if you want to understand its that question, we can understand it like this. What is the say for example, I do take this one. Okay. So what is the number of adult males having their height 160 or less than it? Remember the upper boundary. Remember, when we say less than, this upper boundary is relevant. So 160 or less than it. The answer is cumulate 1, 3 and 29. This makes it 33. On the other hand, for the upper type, what is the number of adult males having their heights 165 or more than it? Remember, when we say more than it, this lower class limit is relevant. When we say less than it, this upper class limit is relevant. And therefore, for this case, all these frequencies are cumulated to make it 88. Or remove all these previous frequencies from 177. This is how we can understand in the continuous case. Next is our probability density concept. This probability density concept actually comes by dividing the relative frequency by the class width. That is 150 minus 145, that is 5. If we divide this by 5, we get this value. If we divide by this 155 minus 50 to this, we get this value, and so on. Now, when we cumulate this probability density, we get cumulative probability density of less than type or more than type. It is generally useful in the sense of curves. When we make curve, say for example, this is an axis and we make curve, and there are suppose class widths. So for a given class width, these relative frequencies or frequencies have been computed. If we divide this by this width, it becomes a density for this given dot point. So this becomes density. I think this is clear now. Okay. Now, coming back to our presentation. So probability density, how do we compute? We have already demonstrated there. By probability density is obtained by divided by relative frequency by the class u minus L, and here relative frequency is divided by u minus L, and this again relative frequency of upper than type divided by u minus L. We get this, all this exam. Okay. In the demonstration, we can show you how. You see here, this is that computation. We get like this. Okay. What we are doing, dividing relative frequency by u minus L, and relative cumulative by u minus L and so on. Okay. Now coming back to our presentation. Now the third example is similar to discrete one, that is regarding the character data. This we have already done. All the computations are very similar as of the discrete, so I will not take much time. Similar computation as of the discrete one. So this ends my lecture today, and I would like to now close my presentation. Thank you. Namaskar. Jai Sri Ram. Jai Shri Krishna.